Hey guys, today we're going to be starting our new unit. Our new unit is on transformations. So, in math, anytime that you take a geometric figure and you change it in any way, if you move it, if you make it bigger, if you make it smaller, if you flip it, if you rotate it, the new shape is a transformation of the original shape. All right. So last year, when you learned about the WUMPs and you learned that you can make shapes bigger or smaller using a scale factor, that was a form of a transformation. In this unit, we're going to review how to make shapes bigger and smaller, but we're also going to learn how to move shapes on the coordinate plane up, down, right, and left. We're going to learn how to reflect shapes across the x-axis and the y-axis, and we're also going to learn how to rotate figures on the coordinate plane. So there are 4 types of transformations that we're going to be learning about in this unit. We're going to start today by learning about translations. Then we're going to learn about reflections, dilations, and rotations. So those are the 4 major transformations that we're going to be learning about in this unit. An important thing for you to know as we work through the unit is that sometimes our transformations are not going to change the size or the shape of our figure at all. They're just going to create congruent figures that might end up in a different spot on the coordinate plane or have changed somehow, but did not get any bigger or smaller. And there are some transformations that actually do change the size and the shape of our figure. All right. And they won't be congruent anymore, but they will stay similar figures. So we're going to start today by learning about coordinate rules translations. And when we say translations, to translate just means to move. All right. So we also call these slides in math class. So that's the first thing that you need to know for today. A translation or a slide just is literally what it sounds like. You're going to pick up the geometric figure and you're going to slide it on the coordinate plane. So a translation slides an object a fixed distance in a given direction. So you can slide a figure up, down, right, or left. You can even slide a figure up and right or down and left. All right. We don't ever slide figures diagonally though. So if it looks like it moved diagonally, that probably means you moved it right and down or up and left. All right. Now, the other thing you need to know, which you might remember from last year, is that whenever you take a figure and you change it or transform it, the new figure uses the prime notation. So if you look down here, the purple triangle ABC was changed to create the new triangle A prime, B prime, C prime. And I remember that because I am a huge Transformers fan. So when I was younger, I grew up watching Transformers on TV. And in 2007, when the real Transformer movies came out, I was like living my dream. All right. Because if you remember, when the semi truck transforms into the leader of the Transformers, he is no longer Optimus. He becomes Optimus Prime. So when you take a figure and you transform it, it becomes a prime figure, just like Optimus Prime. So that's how I remember it. Now, the prime is just a little like apostrophe, you can think of it. I like to think of it as just like a little letter I right next to the letters. So you can see here in the figure above, A prime, B prime, C prime is the image of the original ABC. So this is important for you to know because when you are given figures on a computer exam or on even on a worksheet, they aren't always going to tell you which one was the original and which one is the new one. The way you're going to know if it was the original or if it's the new one is by looking for the prime notation. So the one that does not have any marks is always the original. The one that does have the marks is the image or the new shape. It's the one that has been transformed because it has the prime notation. Sometimes they will also call the original the pre-image. That means that was the image before it was changed. Pre-image means before, image means after. So that prime notation can really help you to understand which is the new one and which is the one that has been changed. All right. So as I said, a translation just slides an object a fixed distance in a given direction. The original object and its translation are congruent figures and they face in the same direction. So you are not rotating anything. You are not flipping anything. You are just taking the figure and moving it. That is it. It is not getting any smaller. It is not getting any bigger. The figure is the exact same size and shape. It's just moved into a different position on the coordinate plane. So the first thing you're going to do today is you're going to start with slides 4, 5, and 6. I have given you the original or pre-image of each figure, and I've given you the new image or the prime image of the same of the figure. You're going to start by just giving me the coordinates of the image. You're going to tell me how did X change, how did Y change, and then you're going to see if you can write a rule that created that translation. You're going to do that for slides 4, 5, and 6, and I'm going to do the first one here for you. All right, so here I have triangle ABC. That's my original or pre-image. I picked it up and moved it to the left. So I'm going to see what the coordinates of my new figure are. So A prime is -2, +1. B prime is -1, +1. And C prime is -1 and +2. So I'm going to look at my X's and I'm going to look at my Y's and I'm going to see how they changed. So A started at +1 and ended up at -2. So how did X change? All right. Well, it moved left 3. All right, because that's what I can see here. A moved 1, 2, 3 spaces to the left. Or you could also say we subtracted 3 because 1 minus 3 is -2. If I look at B prime from B, well, I still moved 1, 2, 3 to the left. So I can put that, moved left 3. And I also subtracted 3 because 2 minus 3 is -1. And then the last one, same thing. It moved 1, 2, 3 to the left. And I subtracted 3 because 2 minus 3 is -1. So I'm just looking at the X values right now. Does that make sense? Now I'm going to look at the Y values here. So 1, 1, 1, 1, and 2, 2. Did my Y values changed? They stayed the same. All right. They stayed the same, So I didn't move up or down. I just moved left. So if we're trying to think of a rule, we're looking at what happened to our coordinates. I can see that Y stayed the same. So I didn't change Y at all. So I'm going to leave Y alone. But if I look at my X's, I subtracted 3 from X. So I would put X minus 3, comma Y as my rule. That's what I think the rule is. And in a few minutes, you'll find out if you're correct or not. We are, because I'm a boss. But in a few minutes, you'll see why it's correct, okay? So that's what you're going to start with first. You're going to do slide 5 the same way I just did slide 4. All right, this one I can tell moved left and it moved down. So not only is your X coordinate going to change, your y coordinate's going to change as well, okay? So don't just look at how many spaces it moved left or down. That's an important part, but also think of the math. Are we adding to x? Are we subtracting from x? Are we adding to y? Are we subtracting from y? Because that'll help you make up your rules, okay? You're going to do the same thing for the quadrilateral on slide 6. And then when you're done, you're going to move on to slide 7. And on slide 7, spoiler alert, this is where you're going to see what actually happens when we add to our x coordinate, what happens when we subtract from our x coordinate, what happens when we add to our y coordinate, and what happens when we subtract from our y coordinate. So I want you to read this little visual. All right, I gave you some examples there. And then I want you to watch this video that is linked right here on slide 7. And that's going to explain all the rules that you should know for this part of the unit. Once you're done with that and you've used this OMG page, you've read it, you kind of get it, you've watched the video, then you're going to go ahead and finish the rest of the slides. So on slide 8, you're going to tell me the transformation that will take place for each rule. So what happens if I add 3 to x? What happens if I add 6 to y? Which way do I move? All right. On the next slide, I give you the movement. You're going to write the rule. So if I move 3 spots to the right and 6 spaces up, what rule is going to make me do that? Then you're going to use your drawing tools to draw an image of the triangle on the grid using the rule x minus 3, y plus 3. Make your new triangle pink. So don't forget, right here, you have shape tools. You can also use your line tools right here. You can go to insert shapes, whatever you want to do to make it easier. I would probably just use the line tools. That would be easier for me than trying to insert a whole triangle, but you do you, all right? Some of you are way more proficient than I am at the computer. You're going to do the same thing for the square on slide 11, except for this time you're using the rule x plus 2, y minus 5, and it says make your new square blue. And then you're going to click the link for the GeoGebra graphing site. This is a really cool site. If you click on it, it looks like this. You're going to create a figure. So you can use any shape you want. You can make a triangle. You can make a square. Keep it simple. It doesn't have to be anything fancy. You're going to create a shape on. So right here, if you go to these tools in the middle, all right, it's been a minute since I used it, so bear with me. If you scroll down, I'm trying to think here. Guess I should have really looked at this before I started filming, but we're in it to win it now. All right. Let's see. I think we can start with a point. So, oops, I don't want to do that. Let's just put a point here. All right. And it even labels it for you. And then you can do another point and another point. And how do we get them to connect? Oh, maybe I should have done that first. A to B. Let's just, all right, you're going to have to play around with it because, all right, there we go. Line, maybe. Let's try line. Oh, geez, that's a whole big line. No, we didn't want to do that. Oh. Jeez Louise. Let's undo that. There we go. Okay, how do I get them to connect? Oh, sorry, guys. This is such a waste. You guys can probably figure this out way faster than me. And you're probably going to laugh at this. I'm sorry. Intersect. Select intersection. All right, let's try this. Let's go back. And let's try attach points and see what happens. Nope, that does nothing for me. I got it to work last year. Nope, nope, nope. No luck, no luck. All right, let's try. Oh, here we go. Maybe we want this. Oh, here we go. Oh, no, that didn't do it. Well, now I lost my tools. Oh, let's try block. Oh, no, that's too big. Boo. All right, here's what we're going to do. I'm going to stop the video and I'm going to put in another video about how to use GeoGebra. But what you're going to do is you're going to create a figure on GeoGebra. I made one here last year. I made a diamond ABCD, and then I used the rule X plus 3, Y minus 5 to move it 3 spaces to the right and 5 spaces down. My new diamond is A prime, B prime, C prime, D prime. And then I took a screenshot of that. So I'm going to get off here now before I make a bigger fool of myself. I'm going to stop this video. I'm going to try to make another video once I figure out the GeoGebra, and I'll put that in for you as well. Sorry this video was long. Do the best that you can today, and I'll see you all tomorrow in person. Bye.